Good morning, one and all. So today, let's start with real analysis 2. So before entering into the code, let's start with some basic definitions. Okay. So you have learned these definitions in real analysis 1, that is in first semester. So we'll just brush up, okay? We'll just go a bit fast. And here, let A be a subset of a set X. Okay, an element A belong to X is said to be an upper bound of A if X is less than or equal to A for all X belong to A. Means each and every element in A is less than or equal to A. ಅಂದರೆ ಎ ಅಲ್ಲಿರೋ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟೂ ಈ ಎಗಿಂತ ಚಿಕ್ಕದಾಗಿರಬೇಕು ಅಥವಾ ಅಟ್ ಲಾಸ್ಟ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಈಕ್ವಲ್ ಟು ಎ, ಓಕೆ, ಬಟ್ ನಾಟ್ ಗ್ರೇಟರ್ ದೆನ್ ಎ. ಸೊ ಇಫ್ ಸಚ್ ಆನ್ ಎಲಿಮೆಂಟ್, ಆ ಥರದ್ದೊಂದು ಎಲಿಮೆಂಟ್ ಎ ಎಕ್ಸಿಸ್ಟ್ ಆಯ್ತಪ್ಪ, ಆವಾಗ ದೆನ್ ವಿಲ್ ಟೆಲ್ ದಟ್ ಎ ಈಸ್ ದಿ ಅಪ್ಪರ್ ಬೌಂಡ್ ಆಫ್ ಕ್ಯಾಪಿಟಲ್ ಎ. ಸಿ, ಐ ಹ್ಯಾವ್ ಜಸ್ಟ್ ಟೇಕನ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. If A is open interval 0, 1, X is equal to Q, set of all rational numbers. Here, 1 is the upper bound of A. See here, each and every element in A is in between 0 and 1, excluding 0 and 1. ಸೊ ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ನಂಬರನ್ನು ಕೂಡ 0 ಮತ್ತು 1 ಮಧ್ಯದಲ್ಲಿರೋ ನಂಬರ್ಗಳು, ಅಂದರೆ 0.1, 0.2, etc. up to 0.9. See, there are actually infinite numbers in between 0 and 1. Okay, so here 1 is the upper bound of A. See, if I take 1 as the upper bound of A, then each and every element here in A is less than 1. Okay, so 1 is the upper bound of A. Okay, and I have taken the second example also here. See here, it is A equal to Z plus, that is set of all positive integers, and here X is taken as Z. Obviously this A is a subset of this X. Okay, and here Z plus doesn't have any upper bounds. Okay, see here, what is Z plus actually? What are the elements in Z plus? Here the elements in Z plus are 0, 1, 2, 3, 4, etc. And it goes up to infinity. Okay, and therefore there doesn't exist any number which is greater than the elements of this set. So we say Z plus doesn't have any upper bound. ಎಲಿಮೆಂಟ್ಸ್ ಏನಿದೆ 0, 1, 2, 3, 4 ಎಕ್ಸೆಟ್ರಾ ಅಪ್ ಟು ಇನ್ಫಿನಿಟಿವರೆಗೂ ಹೋಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಯಾವುದೇ ಥರದ್ದು ನಂಬರ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ ನಿಮಗೆ ಅಪ್ಪರ್ ಬೌಂಡ್. ಯಾಕೆ ಅಂತಂದರೆ ಈ ಯಾವ ಥರದ ನಂಬರ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಬೇಕು ಅಂದರೆ ಆ ನಂಬರು ಈ ಎಲಿಮೆಂಟ್ಸ್, ಈ ಸೆಟ್ಟಲ್ಲಿರೋ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತ ದೊಡ್ಡ ನಂಬರ್ ಆಗಿರಬೇಕು. ಬಟ್ ಇಲ್ಲಿ ಇಟ್ ಗೋಸ್ ಅಪ್ ಟು ಇನ್ಫಿನಿಟಿ. ಸೊ ಹಿಯರ್ this Z plus doesn't have any upper bound for that reason. Okay, so now let's move to the next topic. Okay, it is lower bound. Let A be a subset of a set X. Okay, an element A belong to X is said to be a lower bound of A if A is less than or equal to X for all X belong to A. See, it is something similar to upper bound. See here, each and every element in A should be greater than this A. Okay, each and every element here in A. Andre, there must exist number A belonging to X such that it is less than or equal to X for all X belong to A. See, for example, ಯಾವುದಾದ್ರೂ ಒಂದು ನಂಬರ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತದೆ. ಯಾವ ಥರ ಇರಬೇಕು ಆ ನಂಬರ್ ಅಂತಂದರೆ ಈ ಎಲ್ಲಿರೋ ಎಲ್ಲ ನಂಬರ್ಗಿಂತಲೂ ಚಿಕ್ಕದಾಗಿರಬೇಕು. ಅಟ್ ಲಾಸ್ಟ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್. ಓಕೆ, ಬಟ್ ನಾಟ್ ಗ್ರೇಟರ್ ದೆನ್. ಸೊ ಆ ಥರದ್ದೊಂದು ನಂಬರ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಪ್ಪ ಅಂತಂದರೆ that number is called lower bound. Okay, and here let's take an example. Okay, here a is equal to 0, 1. I have taken the same example here. If a is equal to 0, 1 and x is the set of all real numbers, and here this is a subset of this, and here 0 is the lower bound. Why? Because each and every element of this set 0, 1 lies between 0 and 1. Okay, lies between 0 and 1. So 0 is less than or equal to all numbers. See here in this case it is not equal to, it is less than each and every element in this particular open interval 0, 1. So 0 is the lower bound. Okay, and here I have also taken the second example. If a is equal to 1, 1 by 2, 1 by 3, see here till where it will go? It will go up to 0, 1, 1 by 2, 1 by 3, etc. up to, it will go up to 0, 0 ವರೆಗೂ ಹೋಗುತ್ತೆ. ಇಲ್ಲಿರೋ ಎಲಿಮೆಂಟ್ಸ್ ಹೇಗಿದೆ, 1, 1 by 2, 1 by 3, ಎಕ್ಸೆಟ್ರಾ ಅಪ್ ಟು ಹಾಗೆ ಮಾಡ್ಕೊಂಡು ಹೋದರೆ 1 by infinity ಹೋಗುತ್ತೆ. 1 by infinity ಹೋಗುತ್ತೆ. So it will go up to 0. Okay, so here the lower bound is 0. So you don't have any negative numbers, you only have positive numbers, and here each and every member is less than 0. Okay, so therefore 0 is the lower bound of this set. Okay, and now let's move on to supremum and infimum. See here, let a star, okay, let a, this upper star, superscript star, denote the collection of all upper bounds. See here I have taken 1 is the upper bound of a, and also 2 is also the upper bound of a. 3, 4, 5 all are upper bounds of a only. So here there exist many upper bounds for the same set a. Okay, so similarly for lower bound also there exist many lower bounds. Okay, see you have 0 as the lower bound, also minus 1 is the lower bound, minus 2 is the lower bound. Okay, and it continues. So here also the same thing. Okay, and here what I am denoting this a upper star by, it denotes all the collection, sorry, it denotes the collection of all upper bounds of a. Andre I have taken those upper bounds and I have kept those elements here in this a star. So then the smallest member of a star is called the least upper bound. ಸೊ ಏನು ಮಾಡ್ತೀನಿ ನಾನು, ಅದನ್ನೆಲ್ಲ ತೆಗೆದು ಒಂದು ಸೆಟ್ಟಲ್ಲಿ ಹಾಕ್ತೀನಿ, ಯಾವುದ್ಯಾವುದೆಲ್ಲ ಅಪ್ಪರ್ ಬೌಂಡ್ಸ್ ಇದೆ. ಸೊ ಯು ಹ್ಯಾವ್ ಮೆನಿ ಅಪ್ಪರ್ ಬೌಂಡ್ಸ್. ಸೊ ಆ ಥರದ ಅಪ್ಪರ್ ಬೌಂಡ್ಸ್ ಎಲ್ಲ ತೊಗೊಂಡು ಒಂದು ಸೆಟ್ಟಲ್ಲಿ ಹಾಕ್ಕೊತೀನಿ. ಅದರಲ್ಲಿ ಸ್ಮಾಲೆಸ್ಟ್ ಮೆಂಬರ್ ಯಾವುದು, ಅದು ಏನಾಗ್ಬಿಡುತ್ತೆ, ಲೀಸ್ಟ್ ಅಪ್ಪರ್ ಬೌಂಡ್. ದೆನ್ ದ ಸ್ಮಾಲೆಸ್ಟ್ ಮೆಂಬರ್ ಆಫ್ ಎ ಸ್ಟಾರ್ ಇಸ್ ಕಾಲ್ಡ್ ದಿ ಲೀಸ್ಟ್ ಅಪ್ಪರ್ ಬೌಂಡ್ ಆರ್ ದ ಸುಪ್ರೀಮಮ್. ಸಿ ಲೀಸ್ಟ್ ಅಪ್ಪರ್ ಬೌಂಡ್ ಇಸ್ ಗಿವನ್ ಬೈ ಅದರ್ ನೇಮ್, that is supremum of a, and it is denoted by sup a. Okay, sup of a. And let a, this subscript star, denote the collection of all lower bounds of a. See ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೀನಿ, I have taken all lower bounds, ಅದನ್ನೆಲ್ಲ ಒಂದು ಸೆಟ್ಟಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ. ಅಲ್ಲಿ the largest member of a star is called the infimum, that is greatest lower bound, greatest lower bound of a. Okay, so that is the greatest lower bound of a, or it is also called as infimum, and it is denoted by infimum of a. And here I am just taking the example, the same example, a equal to 1, 1 by 2, 1 by 3. Okay, and here x is set of all real numbers. ಸೊ ಇಲ್ಲೂ ಅದೇ ತೊಗೊಂಡಿದ್ದೀನಿ. ಈಗ ಸುಪ್ರೀಮಮ್ ಆಫ್ ಎ ಅಂತಂದರೆ ನಾನು ಫಸ್ಟು ಗ್ರೇಟೆಸ್ಟ್ ಇದು ಸಾರಿ ಅಪ್ಪರ್ ಬೌಂಡ್ಸ್ ಏನೇನಿದೆ ನೋಡ್ಕೋಬೇಕು. ಈ ಸೆಟ್ಟಿಂದು ಅಪ್ಪರ್ ಬೌಂಡ್ಸ್ ಬಂದು 1, 2, 3 and so on. These are all upper bounds only. But what I want least of all. ಇದರಲ್ಲಿ ಯಾವುದು ಚಿಕ್ಕದಿದೆ ಅಲ್ಲ ಅದು ನನಗೆ ಬೇಕಿದೆ. ಆ್ಯಂಡ್ ಹಿಯರ್ ದಟ್ ಈಸ್ 1. ಸೊ supremum of A is 1. And when I am calculating what is infimum of A, I will take the set of all lower bounds. ಎಲ್ಲ ಲೋವರ್ ಬೌಂಡ್ಸ್ ಏನೇನಿದೆ ಈ ಸೆಟ್ ಅದೆಲ್ಲವೂ ಕೂಡ ನಾನು ಎ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಸ್ಟಾರ್ ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. ಓಕೆ, ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ದಿಸ್ ಆಸ್ ಐ ಹ್ಯಾವ್ ಡಿನೋಟೆಡ್ ದಿಸ್ ಬೈ ಎ ಸ್ಟಾರ್. ಆ್ಯಂಡ್ ಹಿಯರ್ ದಿ ಗ್ರೇಟೆಸ್ಟ್ ಆಫ್ ಆಲ್ ಲೋವರ್ ಬೌಂಡ್ಸ್ ಇಸ್ 0. So here the infimum of A is 0. Okay, and see here we'll move on to next topic, that is monotonic function. A function is said to be monotonic if it is either monotonically increasing or monotonically decreasing. So now we'll move to monotonically increasing function and decreasing function. So what is, see, this is a function is said to be monotonic if it is either this or this. So now let's define what is this. Monotonically increasing andrenu, monotonically decreasing andrenu ಹೇಳೋಣ. Okay, so monotonically increasing function, a function f of x is said to be monotonically increasing in domain D if for each x1 x2 in D, x1 less than x2 implies f of x1 less than or equal to f of x2. ಅಂದರೆ as in when we increase the value of x, f of x also increases. So this means that only ಇದನ್ನು ಈ ವ್ಯಾಲ್ಯೂಸ್ ಡೊಮೇನಲ್ಲಿರೋ ವ್ಯಾಲ್ಯೂಸ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂಡು ಹೋದಂಗೆ ಅದ್ರದ್ದು ಇಮೇಜಸ್, ಅಂದರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ x1 is less than x2, okay, ಅಥವಾ if x2 is greater than x1, then obviously f of x2 will be greater than or equal to f of x1 for monotonically increasing function. So similarly, monotonically decreasing function ke a function f of x is said to be monotonically decreasing in domain D if for every x1 x2 belong to D, x1 greater than x2 implies f of x1 less than or equal to f of x2. See, it is just opposite of this. As in when we increase the value of x, f of x should decrease. See, if I increase the value of x, the f of x value should decrease. That is monotonically decreasing function. See, also we talk about strictly increasing and strictly, what is strictly increasing? What is the difference between strictly increasing and just increasing? See here, strictly increasing means this equality sign will not be there. It is just f of x1 less than f of x2. But what about strictly decreasing? F of x1 less than this one. Means here, as in when we increase the value of x in domain, the value of f of x. See, if x1 is mapped to f of x1, x2 is mapped to f of x2. Okay, so this is domain and this is codomain and this is f, and this continues. And here x2 is greater than x1, x3 is greater than x2, and it continues. Then what is this monotonically increasing telling? F of x2 should be greater than f of x1, f of x3 should be greater than f of x2, and at last it can be equal to. But what happens in strictly increasing is it cannot be equal to, it must be greater than this f of x1, and this f of x3 should be greater than f of x2. So this is how it is in strictly increasing function. And in strictly decreasing function, it is the opposite of that. See, if x1 is greater than x2, means x2 is less than x1, x3 is less than x2. See, this is decreasing, then this must be increasing. then we say that it is monotonically decreasing function. If it is strictly decreasing, then what is that? Strictly decreasing means if it is decreasing, then it should be increasing. If x2 is less than x1, then f of x2 should be greater than f of x1. Okay, so this is the meaning of strictly decreasing. Okay, now we'll talk about bounded function. See here, a function f of x is said to be bounded if it has both upper bound as well as lower bound. See, you all know the definition of boundedness. When we'll call that set is bounded if it has both upper bound as well as lower. This you have learnt in first semester. See here, now we are talking about bounded function. Bounded function ಅಂತಂದ್ರೆ ಆ ಫಂಕ್ಷನ್ಗೆ ಅಂದರೆ suppose if this is the domain and this is the codomain for this function f. If this domain is mapping to this range R, this set R must be bounded. Means it should have both lower bound as well as upper bound. Then we say that this function is bounded. So this is all about bounded function. So thank you. Let's